Hello guys and welcome to this recitation on fundamentals of Numpy. In this recitation, we'll be covering the fundamentals notion that you need for this deep learning class. We'll basically go through the means of Numpy, how we can install it and create array and manipulate array using Numpy. We'll also look at how we can modify data that we've created with Numpy and how to pivot the data, how we can combine data from different arrays, and look into some more advanced operation that we can do with Numpy. In this deep learning class, we are covering just the basics of notion that you need for most of your deep learning assignment, because you will be programming from scratch your own version of PyTorch that we'll call MyTorch. So let's get started. What's in Numpy? Numpy is a fundamental package for scientific computing in Python. It's a library in Python provided that help us to perform several operations, from mathematical operation like logical operation to basic linear algebra through some random simulation and much more. Firstly, we need to have Python NumPy installed in our Python environment before we start doing any kind of operation. If you're working with Colab or AWS environment, you should know that NumPy is already installed in this environment, but you can still check if it is available. So if you're not using AWS or Colab as an environment, you can try to check if your working environment already has NumPy installed. So to do that, you will need to use the pip show NumPy command. If NumPy is already installed, you can go ahead and import it in your environment, in your code, and start working with it. But if it is not installed, you will need to install NumPy using the pip install NumPy command. So basically here, as you can see, NumPy is already installed in my environment because I'm using Google Colab. But if it is not installed, you will not see it. As this is already installed here, you can see that we have the version and some other details on the package itself. So now that we already have our package installed and imported in our working environment, we look into how we can use NumPy to do some operation. One of the first operation we like to do here is to know how we can create an array, because most of the operation we'll be doing will be to perform operation on tensors and vectors, which are basically arrays, and we'll have them in different dimensions. So let's look at how we can create an array of one dimension using NumPy. In NumPy, we have several methods to create several functions available to create a one-dimension array, but one that we'll check here is the arrange function. This function allows us to create a one-dimension array just by providing the number of elements we want. So if we do it that way, by not providing the type and any other stuff, we'll just get an array of integers. But if we want, we can also provide some other parameters available for the arrange function, which are optional parameters. One of the values that we can provide is the start, the begin, and the end with the step that we want to use. This is for NP arrange. The same way, we can also create one-dimension array using the linspace method, and it also receives similar parameters. But here we can say, as we can see, we provide the start and the end and the number of elements that we want. This automatically creates an array of one dimension, and you will see that we have the same space between each of the elements of the array. Another way, we can also create an array of multi-dimension. For instance, here we create an array of 2 dimension. of size 2 by 2, which is the shape. And we use 3 different ways of creating array here. The first one that we use is the empty function from the Numpy package. The empty function will just need you to provide one of the parameter, which is the shape. And when you provide the shape, automatically this will create an array that has the shape that you define, and it will be filled with random values. But if you do not want to have random values for your array, for instance, if you want to create an array filled with 0 everywhere, then you can use the function zeros from Numpy package. This function also will need you to provide the shape of your array, and this can be any type of dimension that you want, from 1 to n dimension. So you can create a tensors of zeros. This is usually used for this deep learning class because sometimes if you want to initialize your weight and you want all the values for your weight to be at 0, or maybe the bias for a simple operation you want to do in the deep learning class here, you can just create an array of zeros. You can also do the same thing for an array where everything is filled with ones. So by executing this set of operations, you will see that the first operation allows us to create an array, an empty array. The second one, we created an array filled with zeros. And the third one, an array filled with ones. Something more interesting that we could do with NumPy is to create an array filled with 0, but using another array. This will automatically create an array with the same shape and the same type of array that you have, but all the values filled with 0. If you use the operation of np ones like, it's a bit similar to what we've done for np.zeros like, but this one will, this time around, create an array filled with value, which is basically be 1. And this array will be of the same type of the one we provided as parameter. So let's continue and see how we can also create an array. We can also create other arrays filled with any given value that we want, just by providing the shape and the value that we want it to fill with by using the function np.full. This function provided in the NumPy package will just create an array of the provided dimensions, so the shape of the provided shape and this type, and also the number of elements we want to the value, sorry, we want it to be filled everywhere. Another way to create an array filled with a given value is to use the np.full-like function. This will require us to provide an existing array in NumPy, and then we also need to give the value that we want and the type of data we want it to be filled with. And when we do it here, we create a full-like array which is filled with 0.1, for instance, and is of type double. So this is what you can see in the output. We also have different other way of creating an array. For instance, we can create an array from a normal Python list, this just by using the np-arrays function. So if we have an array from usual Python, a normal Python list, we can provide this to the np.array function, and this will automatically transform our arrays into a Python object for manipulation. So from that, we'll be able to call some of the method or maybe a function available in NumPy for this particular object that we've created. So we can check the shape of the newly created array in NumPy and do much more things with it. We also have other interesting way of creating a NumPy array. This by using some random simulations. So here we can create an array filled with integers, but we'll provide the range of value that we want to use and also the shape, the size. So this will automatically create an array of the size that we've given to the function roundInt, which is in the random module in Numpy package, and with the values between 0 and 10 that we provided here. We can also do it just by setting a seed to the random module. This will help us to generate an array using the seed that we provided. We also have much more way of creating an array in NumPy. And one of the way is if you want to use to draw sample or maybe numbers from a given distribution, then we can do that. And an example that we've done here is by creating an array filled with a number coming from a uniform distribution over 0 to 1. And you will see that once we've done this created an array from the uniform distribution filled with value between 0 and 1. And you can see it here. And this array is of dimension 3 by 2. If we also want, we can generate number from a Gaussian distribution. So for that here, we define the mu and the sigma parameter for the Gaussian distribution. And we use the np.random rand function to allow us create a sample of an array filled with value coming from that Gaussian distribution. So in this recitation, we cover different ways of creating an array, and this will be helpful for you guys when you will be completing your assignment for your semester. But one interesting thing is you need to take time and go through this and make sure that you understand the different way that we can use to create an array. It will be a lot helpful for you for the first part of your assignment in this class. Thank you for watching and see you in the next video where we'll be covering some notion on how we can access data that are available in the array that we've created. And we'll also look into some more advanced methods that we'll use to modify the arrays or combining data and pivoting and much more operation. Thank you and see you.